the properties of elements in the periodic table. So let's define the first property we're going to look at is what we call the first ionization energy. Now this is the minimum energy required to remove 1 mole of valence electron from 1 mole of gaseous atom to form 1 mole of gaseous charged ion. I can see you're just saying so many 1 mole, okay, because we have to have a specified quantity. For metals, for metals group 1, group 2, it's easy for them to lose electrons. Metals lose electrons to become positively charged, okay, cations, okay. So that means the energy required for them to lose that electron is likely going to be small. They just need a little energy to lose electron, okay, because they have fewer valence electrons, okay. So that means that group 1 and group 2 tend to have small ionization energy. That's little energy. They have the smallest energy required in order to become cations. So you see, that is the energy that is required to lose an electron. So ionization energy simply describes electron loss or electron removing, and it's an endothermic reaction. So it's measuring the amount of energy required that will be absorbed, that will be necessary for an atom to lose an electron. Right, okay, so let's talk about electron affinity. Electron affinity, which describes electron gaining, it's like the opposite of what we just discussed, ionization energy. Let's define that. So these definitions are very important. That's why I sent you the notes. If you want your full mark in a standard exam, give the definitions as close as possible. So this is the energy released. So ionization energy is energy absorbed, while electron affinity energy released, that energy given out when 1 mole of gaseous atom acquires 1 mole of electron to form negative ion. So that's why it's at opposite. This one is electron losing, this one is electron gaining. So it's an exothermic reaction, okay, and it increases across the period, okay. So you know that for non-metals, non-metals are group 6, group 7, thereabout. So electron affinity increase across the period. So electron affinity, I said, describes electron gaining. So you can imagine that non-metals or elements that become negative ions, okay, that have a lot of valence electrons, like chlorine, your group 7 elements, chlorine, fluorine, and the likes, it's easier for them to gain an electron, okay. So for where 1 mole acquires 1 mole of it, so they gain electrons, so they have a lot of energy is released to become anions. Non-metals release a lot of energy, so the electron affinity tends to be highest. Let's talk about atomic radius. The atomic radius of an element is simply half the distance between the nuclei of 2 atoms that have a single covalent bond. Okay, you might have discussed bonding in your school. It's just the sharing of electrons between atoms in order to form a compound or molecule. So if you have 2 atoms that are bonded together, the distance, half of that distance between their nuclei is the atomic radius. So we have half of this d, so it decreases across a period but increases down a group. Electronegativity is the 4th property of elements in the periodic table we are going to look at. So this is a measure of the ability of an atom in a molecule or bond to attract a shared electron pair to itself, like maybe water, for instance. Okay, you have your water, maybe you have H2O, right? So you have water, you have oxygen, and you have hydrogen here. So the ability of the oxygen to attract a shared electron pair to itself, okay, is the property of electronegativity. Electropositivity is the tendency of an atom to donate electrons and form positively charged cations. Electropositivity is the tendency of an atom to donate electrons and form positively charged cations, okay, and it's usually exhibited by metallic elements. Now this is very important. Metallic character decreases across the periods from left to right and increases down the groups. The metallic character of an element is its ability to lose an electron during a chemical reaction. The metallic character of an element is its ability to lose an electron during a chemical reaction. Okay, so the elements in the bottom left of the periodic table have the lowest ionization energy IE stands for ionization energy, and also the lowest electron affinity, EA, electron affinity. What do we mean? See, look at the trend. Metallic character, it decreases as you go from top right to bottom left. Okay, so that's said about metallic character. Thus, they are most metallic. That is, the alkali and alkaline earth metals, the group 1 and group 2 metal. They have the lowest ionization energy and the lowest electron affinity. There's a reason why I'm repeating this concept. It's very important. On the other hand, let's talk about the non-metallic character. Non-metallic character is the ability of an element to gain an electron during a reaction. So you must know that is the non-metallic character is increasing as you go from bottom left to top right.